Hey there everyone, all the techies and data enthusiasts there. Welcome back to my channel. So guys, this is video 9 of our Transformers series, and in this particular video we are going to discuss about Transformers complete architecture. So I have created a complete architecture diagram. So we'll be discussing about that, and guess what guys, today we are going to practically implement the project. I'll run a project in front of you all and I'll show you an example how does a transformer works, and it's a workflow actually. So we'll be discussing about that in detail. So guys, what are we waiting for? If you have not subscribed the channel, do subscribe the channel and on the bell notification. Now let's get started. So guys, here is our final architecture of transformer. So until now we have discussed everything in bits by bits. So I broke all the components, right? So one by one we have discussed about embeddings, what is positional encoding, and multi-head attention, masked multi-head attention, what are self-attention models. So today we will be discussing the complete architecture, both combination of encoder, decoder and its components. This particular image we have personally designed it so that you can understand the transformer architecture clearly. Okay. So let me just show you all this. So the one which is on my left hand side, in our left hand side, this one is our encoder model and this is our decoder model. Okay. So let me just break through you all with an example here so you can understand this architecture completely. Then guess what guys, we will be practically implementing the code as well. Today we will be doing a project in which you will be using digital bird to work with it and to get the output. So pre-trained model, how you are going to use it, you will learn that as well. So it's going to be a very interesting video. So now let's get started. Input. So once we have to first provide input to our transformers, right? So this is the one which we are going to provide the input here. So whatever input you provide in, that is sent to input embedding, so that has been embedded. Later the positional embedding is done, and after that it is been sent to multi-head attention, and residual connection and layer normalization is also done here. So here I have given only this three dots, but it can be how many ever you want, that many multi-head attentions you can create it. So 1, 2 and so on n. Okay, so I just designed like that. And after that you have the feed forward neural network. Once you have attention done, those attention scores and everything, you will be sending it to feed forward neural network. And here also the feed forward neural network is nothing but your ANN, the first neural network which you call it as well. So that particular neural network you will be sending in, and layer normalization is again done. So in each and every step definitely residual connection and layer normalization will be done. So don't get confused on it, it's common. After this we send it to multiple feed forward neural networks are done, so on n. Okay. And after that we get the output. Whatever output we get, we will be feeding it to decoder model, which is on my right hand side now, which you are seeing here. This is our decoder model to masked multi-head attention. Before that, this is all this right hand side, whatever is there, right? This is our encoder one. I hope you got it. It's very simple. Input embeddings are coming in and positional embedding is done, and after that it is sent to multi-head attention and layer normalization is done. Then we send it to feed forward neural network, and again after normalization we get the output. Whatever output we get, we feed it to masked multi-head attention. Okay, and here again you have output. You guys might think, why is it output here, what is this? So here in output what it does is, in decoder, so whatever we gave the sentence at the first, so for example the cat sat on the mat. Okay, so that all the process is done of the encoder and it is sent, masked multi-head attention gets the encoder output here. But again we send here the cat sat on mat output, and we embed the output and positional encoding is done. Then multi-head attention, and after multi-head attention we send that also to masked multi-head attention. So here the score which the encoder sends, that we will be comparing it with the output as well. This is the score. The cat, for the cat we get the score from encoder model, and here the original word we add the score to it. So that is also done here. Those comparisons are done, and masked multi-head attention and adds and norms are done here again, layers normalization and residual connection, so on n. This masked multi-head attention, if you remember, that is the reason before I start with decoders, I explained about it, then I started the decoder concept. So that is the main reason. To in encoder you don't get masked multi-head attention, but in decoder masked multi-head attention is must and should. Okay, to understand that, that's the reason I created a video on it. If you haven't checked that, go and check out in this Transformer Simplified series. That is also one of the video. This is the 9th video, right? So before that, whatever videos are there, in that all these topics I have already explained. Make sure to go and check it out. After that, whatever we got, then we finally send it to feed forward neural network again. So after feed forward neural network, so on n neural networks are created, and after that we send it to linear transformation, and the softmax is applied to it. Finally we get the output. This is the entire decoder architecture, which is at the right hand side. Combining this both, it is encoder decoder architecture. For encoder, only stacking of encoder you get BERT model, pre-trained model. Stacking of decoders you get GPT models. So if you want me to explain this also in detail, make sure to comment below. I'll create the continuation series of on all pre-trained models, like what is BERT and what is GPT and how they came in. So the chat GPT which you are using, chat GPT, chat with generative pre-trained models. So that GPT full form is that only, generative pre-trained models. They are generative models. Okay. So about them you can detailedly understand what is the behind workflow and everything. So the ChatGPT evaluation came from this particular transformer architecture only. Not only ChatGPT, this Anthropic, Ideogram, and all the image generation tools like Leonardo and stable diffusion. All these models, base model is your transformers. Without transformers and without understanding this transformers architecture, those models will not come in, and it would have been not at all introduced as well. To say frankly, without transformers, we wouldn't have been entered to this AI era as well. So this model played a very crucial role. It was launched on 2017. So I hope you understood this complete architecture. If you have understood this architecture clearly, then guys, to in interview like this in 15 minutes, or not in 15 minutes, 5 minutes, you can easily explain this concept and the interviewer will get shocked. So this will be helpful for you all for your future references. Make sure to save this somewhere else. So I'll provide this link in this video description. You can check out the GitHub link and add it to your saved list or star it. Okay. Now let us see the coding part. Okay, about those pre-trained models. So let me connect. I have a project here. Sentiment classification of movie reviews. For this we'll be using digital BERT. It's a practical implementation. Okay, so let me connect it with T4. So T4 is free to use in your Google Colab. I'm using Google Colab. Make sure to use T4 only. So this code also you will get at the last after this video, in the description. Real world use cases, product review analysis, understanding customer feedback and social media monitoring and customer support system. These all are the things which you are going to solve it. Okay. Automating the process of categorizing customer queries and prioritizing negative sentiments and positive sentiments. Okay. For this, reason for using sentiment classification: to improve the decision making and automate the insights, better customer experience. So if you don't do sentiment classification of the user's review, then how you will understand what are the faults done in that particular movie and how can we improve it. Based on the negative and positive feedbacks only we'll understand, right? Solution, we will be using digital BERT, the lighter version of the BERT model. BERT is nothing but bidirectional encoder representation from transformers. So it's a stacked encoder. Only encoder is used in this. Decoder doesn't come into this model. The stacking of encoders, you get BERT model. Okay, which is designed for efficient NLP tasks. Transformers are pre-trained language models to learn contextual representation of text. Okay, so we'll be using the IMDb dataset for now. We'll be loading the data and tokenizing it and fine-tune the model, and we'll evaluate and predict. So that you will practically see here. First install all these libraries. After installing them, you can run this. Okay, we are importing those required libraries. So it will take some time to import these libraries actually, especially from transformers. You are importing digital bird tokenizer fast and digital bird sequence classification trainer and training augment. So these are been imported from transformer, right? So it will take some time for this to understand. You can see it's completed. From datasets, we are loading datasets. So we have IMDb dataset in datasets library. So we'll use that only, and import numpy as np. And from sklearn.matrix we are importing accuracy, precision, recall, F1 score, support. Okay, and we are importing torch, PyTorch. Okay, now let us load the data set. Okay, let us print the first 5 data set, like positive, negative, even labeling is done, negative review, positive review, everything is mentioned here, and we have the review details. Okay, so this code does the same, so we used for loop here in short. Okay, and now we are initializing the digital bird. So tokenizer is equals to digital bird fast dot pre-trained. So from digital bird fast tokenizer we are importing digital bird uncaged model. Okay, so digital bird uncaged we are calling it. You have digital bird large as well. So there are different categories in which we are using digital bird uncaged. Okay, and after this what we'll do, we'll tokenize the dataset. So whatever dataset we are having, right, we are tokenizing it. We wrote a function called tokenize and we are padding it with maximum length, and truncation is equals to true, and example is equals to text. We are giving that and we are tokenizing it. We are creating it in the form of IDs and attention masks. We are masking it. After this, okay, before this completes, right, I have an important information for you all. Have you all ever heard about Mamba architecture or Mamba model? You all know about transformers, right? So before that we have RNNs, LSTMs and GRUs. So I created a video recently on it. If you haven't checked it out, my previous video was on it only. Make sure to have a look on it. There is one, like you can say, one architecture called Mamba architecture, in which you can say it's very fast compared to transformers. But I don't know why that architecture was a failure. If you want me to explain more about this particular architecture and you want to know reasons why transformers surpassed it and what happened to Mamba, actually still they are developing it, but I don't know why that particular model is not up to the mark, or it's not in that level of trend right now. So if you want me to explain about Mamba architecture, make sure to comment below this particular video. I'll definitely research about it and I'll create a detailed video on Mamba architecture to understand what it is and why it became such a famous, and how transformers, because of transformers, how it did not succeed, it became a failure. Okay, it is going to be a very interesting case study for those who are learning data science, or the like scientific researchers who are writing researchers. For them it is very important to know about Mamba. So you can comment below, I'll definitely create a video on it. Okay, now this is done. Now let us run this one as well. So attention scores you can see here, and the label IDs all are in tensors. So these are the tensors which have been created for it. And now split the data into train test and training and validation data set. Testing is not there. Okay, training and validation. So here you can see the training size is 10,000 and evaluation size is 2,000. So we have splitted it. Now what we are doing, we are defining a simple evaluation matrix. Accuracy, F1 score, precision and recall is here. Now we can run this. So this is a function for the matrices. So I have created a function here, compute matrix, and in this we have mentioned all this. Now later again we are going to use distal but uncased, and we are loading it, we are storing this particular model in a model variable distal but uncased. Okay, and we are defining the training arguments. Here you can see we are defining the training arguments, saying that output directory is /results, it should store in results, and evaluation strategy is epoch, so based on the epoch it should evaluate, and pre-trained batch size is 16 for both evaluation and training, and number of epoch is 1, and weight decay is 0.1. Okay, so we are defining this training arguments. Then finally now we will start with the training. Trainer.train is running right now. So it should start to load right now. Okay, it's asking me to wannabe.ai. Okay, let me do this. Okay, so guys, for this it's actually asking the weights and bias authorization key. Why weights and bias? Because it will store all the weights and model weights and updates in that particular weights and bias account. So it's not a problem. Let us create it. This company or institution. So it's asking for company. So PW skills. So if you all don't know, I'm actually working on physics wala, right? Yeah, physicswala.org. So mobile number it's optional, right? Let it to be left optional only. So programming and for professional, personal. Continue. Organization URL, continue. Okay, now I got this, right? So now what we can do here in weights and bias. So here you have your API key here, you can see. You have to just create an account of weights and bias. You will get this API key. So copy this API key and paste it here. Enter. So appending key, version, done, run. So now the run has been started here, you can see. Okay, so don't worry, I'll just delete this account again because my API key is being exposed, so that's the reason. I'll go and I'll delete this account, however, at the end of this particular video. So role, admin, member, contact, sales, privacy. Link users, okay. There should be a option here to delete it. I'll delete it later. So here I should get it. Yeah, delete the account. So you want, you can even delete this account. So let this to be done, then I will delete the account immediately. So let this training to be done and let us evaluate, and the video will be done for after that. Okay, I'll just pause the video until this training completes. Okay. So guys, here you all can see my training is completed once we gave the weights and bias API key. So it got started to train, right? So it's done now. We got the validation loss here, and accuracy is 91, F1 score is 91, precision 92, recall 91. Okay, so the training is completed. Now let's evaluate the model. So evaluation is again started here. So evaluation will be done. Yeah, it took me approximately 15 minutes to complete the training. You can see here. With T4, if normal systems, if you run, definitely the system will be crashed. Okay, so make sure to use Google Colab for training this particular model. Okay, so this is also done now. Now what we can do is, as this is also done, so evaluation loss is same, and evaluation accuracy, F1 accuracy, everything is here. So we can test the model. So it's almost same here. So let us start to test here. So we have some reviews here. The movie was fantastic. I really enjoyed it. I hate every movement. Okay. So almost 1, 2, 3, 4 tests are there. So let us run this. Reviews and Kuda. Model evaluation. Now let us print this. You can see here, the movie was fantastic. I really enjoyed it. So it's a positive sentiment. I hate every movement. So it's a negative sentiment. It was an average experience, negative sentiments. I absolutely loved the product. Will recommend it to everyone. So it's a positive sentiment. Approximately this complete training, if you see here, it is the best example to understand what is this what is this transformers and how it works internally, and how it works especially with the pre-trained models like BERT base or BERT uncaged, digital BERT. Okay, with these kind of models. So there are many pre-trained models. If you want me to create a complete series on this pre-trained models only with practical code explanation, make sure to comment below this particular video. I'll definitely create it, and even Mamba as well. So whatever you want, make sure to comment below this video. I'll be seeing each and every comment. I'll definitely create a video on it. So guys, that's all for today's video. Do like, share and subscribe the channel, and make sure to stay updated. So on the bell notification to stay updated. I'll come up with a new video again. Bye bye.